river environments, and we're looking at the hydrological cycle, which, as the name suggests, is all to do with water. Let's start with the definition. So the hydrological cycle is the global circulation of water. It is a closed system made up of both stores and transfers, and we'll be looking at what those stores and transfers are in a great amount of detail. But what do we mean by a closed system? Well, it basically means that water can neither leave or enter the Earth's surface or atmosphere. What do we mean by transfer? Well, that's the movement of water between stores, and there's lots of different transfers you need to know about. The first one is evaporation. Evaporation is when heat energy causes the temperature of the water to rise until it turns into steam and forms clouds. Next up is transpiration. If you do biology, you'll know all about this. It's where plants absorb water at their roots and then they transpire that water out of their leaves. And I'm trying very hard not to mention stomata, etc., because as geographers, you just need to know that that water evaporates from the surface of the plant's leaves. A term which you may have heard is the combination of those two terms, and that is evapotranspiration. Condensation now, which is the opposite of evaporation, that's when that water vapour cools and condenses, turning back into a liquid, and that's what you often find occurring at clouds. Now, precipitation, that's effectively when water transfers itself from the atmosphere to the Earth's surface. So it includes things such as snow, rain, hail, that sort of thing. Slightly more complicated now, surface runoff, that's when water falls as rain and then it runs across the Earth's surface into surrounding streams and rivers. Through flow is when water drains through the soil due to the force of gravity, and again that water will collect in streams and rivers. Groundwater flow occurs in rocks of the aquifer. Remember, an aquifer is a porous rock that allows water to drain through it, and in this way water will reach seas, rivers and lakes. So those are the different types of transfers you need to know about. But what sort of human factors can affect the amount of transfer that occurs? Well, the first main one is urbanisation. When we build cities and towns and we pave and we concrete and we tarmac the surface of the earth, that basically increases the amount of runoff that occurs, because obviously that water is not draining into the soil, it's not draining into the aquifers in the same way. And you will find that urbanisation does lead to an increase in the speed at which these water transfers occurs. Deforestation, that's another human activity. It means cutting down trees. Remember, we cut down those trees for building materials, to provide land for farming, fuel, etc. What happens when we deforest is we lose the topsoil, because it means we no longer have the tree roots holding down the soil, and again that will increase surface runoff. We've looked at human factors, but what about physical factors which affect water transfers? So the first one is rock type. You'll find that non-porous rocks will allow water to run off far more quickly because that water won't be soaking through the rock. Vegetation will also have a large effect. If you have more trees, then that will increase the rates of rain interception, as well as increasing the rates of transpiration, and as a consequence, evapotranspiration. We'll touch a little bit on storage here, because the third physical factor which will affect water transfers is global warming. As temperatures increase, you will find that the stores of ice and snow reduce. However, there'll be an increased transfer to our seas and oceans due to increased precipitation rates. We will now deal with water stores, and that's where water is stored within the hydrological cycle, and that falls into three broad categories. That will be land, sea and the atmosphere. So we'll now go through those in a lot more detail. First of all, lakes. Now, water is stored in lakes because it has a bottom made up of a non-porous rock, which means the water can't drain away. Rivers, hopefully, are quite self-explanatory, as well as the sea. You find that soil is a good store of water because that water can't percolate through to the bedrock. Other examples of good water stores that you need to mention in your exam are groundwater, surface water, clouds, ice, and then that aquifer, which, remember, is a porous rock that allows water to drain through it. Sometimes it's useful to see a pictorial representation so you can understand how all the stores and transfers are linked. So because it's a cycle, it doesn't really matter where you start. But let's have a look down here. So heat energy causes the water's temperature to rise, it becomes steam, it evaporates up to form clouds. We said that any water coming from the clouds in the form of hail, rain, snow is examples of precipitation. So that's what we can see here. We can see ice falling over there. Through surface runoff, where that water runs over the Earth's surface, we know that water, due to gravity, will lead to rivers, lakes, streams, etc. So we can see how the water is returning to the sea as a store. Vegetation interception we already talked about, which is a physical factor affecting water transfers. Those trees will be absorbing that water at their roots, Transpiration will be occurring as a result of that. Then down here we have examples showing through flow and groundwater flow. Remember, through flow is due to gravity, where water drains through the soil until it reaches either a stream or a river. Groundwater flow occurs in rocks of the aquifer. Remember, that's your permeable rock, and involves the transfer of water to lakes, rivers and the sea. So you can't see absolutely everything on this diagram, but I'm hoping you understand how water is stored and how that water is transferred. And remember, this is a closed system. Water is neither allowed to leave or enter the Earth's surface and atmosphere. Now we're going to move on to the drainage basin. What is a drainage basin? Well, it is an area of land drained by a river. It's an open system, and that means that the amount of water varies over time due to changes in external inputs and outputs. So what sort of inputs are there of a drainage basin? The first one, which is probably the least obvious, is energy from the sun. But then let's think about, how would water be added to a drainage basin? Well, precipitation is a good method. So remember, that's anything that falls from the sky, rainfall, snow, hail, etc. As well as water from tributary basins. Remember, a tributary is a small river which joins the main river channel. What about the outputs of a drainage basin now? So how does water leave the drainage basin? Transpiration and evapotranspiration is going to be important here. Remember, transpiration occurs from the leaves of plants, as well as the river's discharge, which we will spend an awful lot of this video discussing. Just one thing to point out, a drainage basin is very different from a hydrological cycle in that a drainage basin is an open system. As I said previously, the amount of water that enters and leaves varies, unlike the hydrological cycle where the total amount of water remains constant. Now we're going to talk about characteristics and features of the drainage basin. So remember again, that's the area of land drained by a river. The first thing you need to be aware of is the source, and that is the origin of the river. Next up, the watershed. That is the boundary of the drainage basin. It's a raised piece of land which separates one drainage basin from another. The channel network is, if you think about a river, it's covered by a network of tributaries. So that channel network is that area of land covered by both the river and its tributaries. The mouth of the river is the point where the river ends, and that tends to be at a sea or an ocean. And finally, catchment, that is the area within the drainage basin. Now there are three different types of drainage basin. First up, those that collect water and deliver it directly to the sea, so they'll be the ones you're most familiar with. Some drainage basins form part of much larger river drainage basins. A good example of this is the River Negro, which is in South America. Now you'll find that its drainage basin forms part of the huge drainage basin of the River Amazon. And then finally, some drainage basins don't drain to the sea or ocean. Instead, they drain to inland seas or lakes, and a good example of this is Lake Victoria in Africa. Next up, river discharge. As we've already mentioned that as being an output of a drainage basin, the river's discharge is the volume of water carried by a river at any one place. So what factors affect the river's discharge? Well, first of all, the most obvious ones are things like precipitation, and particularly rainfall will affect river's discharge. So remember, that's the volume of water flowing at any one particular place. Obviously, if it rains more, there will be a greater river discharge. Second up is vegetation. Now, if vegetation is cut away, it exposes bare rock. This reduces the time taken for the water to be soaked up, leading to an increase in the river's discharge. The good thing about trees and other vegetation is their presence intercepts that rainfall usually, and therefore delays that rain reaching the ground and has the subsequent effect of reducing the river's discharge. Other factors which affect the river's discharge include soil type, length and width of river, and the number of tributaries, so small rivers which join that main river channel. In terms of human activity, urbanisation has a detrimental effect and will increase river's discharge. This is because urbanisation, so building of settlements, increases the rate of surface runoff and therefore decreases the lag time. This will increase the peak in river discharge. Urbanisation also automatically means that vegetation will be cut down. So as I was just saying, that means that there'll be less interception of rainfall, meaning that there won't be that delay in that water reaching the ground. So you'll end up with more surface runoff and greater river discharge. Now we'll turn our attention to river regimes. First of all, let's start with the definition of a river regime, and this is the way in which the river's discharge changes over time. Remember that the river's discharge is the volume of water carried by a river at any one place. So we need to consider why would that volume increase or decrease at any particular point in time. We do also like to look at it over the course of a year so we can make predictions and understand more about the behaviour of a river at any particular season or point in time. So if we consider the sort of things which will increase the river's discharge, well, first of all, heavy precipitation, so heavy rainfall, what that means is that the ground gets saturated very quickly, which increases surface runoff, meaning that there's a shorter lag time, so that water that falls from the sky will flow directly into the river, so that will influence the river regime in that way, increasing the river's discharge. If we increase the temperature, so hotter days, there'll be more evapotranspiration, so that will remove water from the river. What about vegetation now, so more biotic factors? Well, vegetation such as trees will intercept that rainfall, meaning that there's a bit of a delay in that rain reaching the ground. So you'll get slower infiltration of the ground, and that will increase the lag time. So that means there'll be a delay in that water reaching the river. In terms of land use and humans' activity, this can actually alter the river regime in opposing ways. So for example, humans might put in drainage channels, more canals. So obviously that will take water away from the river. However, urbanization generally, and by that I mean building settlements, what that means is there's less ground for that water to soak into, to infiltrate. So in this situation, you'll end up with more surface runoff, and that water will wash into the rivers, meaning that there's a decreased lag time. So look at it from 2 points of view. Either human behaviours which will divert that water away into canals, into drainage channels, or the fact that we're building more, concreting our surfaces, meaning that you get more surface runoff and therefore greater river discharge. And in that latter situation, you will find that that creates more of a flashy river regime. Other things humans do could include water abstraction, and that's where humans remove water from the river for particular uses. That could be in industry, that could be to water crops, so irrigation, or that could even be for consumption purposes, washing, cleaning, etc. And then lastly, dams. Again, this is something that is human built. Dams are often built in order to trap water within a reservoir, and then through the process of HEP, so that's hydroelectric power, these dams are used to generate power for our homes. Again, that will affect the river's regime. So broadly speaking, if you're asked to describe the factors which affect river regime, let's talk about precipitation, let's talk about temperature, let's talk about vegetation, land use, water abstraction and dams, and break your answer up into those various categories and provide the extra details that I've already given you previously in this video. A storm hydrograph, graph which shows how a river's discharge changes over time, and that's typically before, during or after a storm event. Why are storm hydrographs so useful? Because they provide valuable insights into the relationship between rainfall and river flow, and that's important because lots of people build their homes within drainage basins, and a huge amount of time and money is spent building these homes. So storm hydrographs provide valuable insights that enable you to predict floods and understand how bad those floods will be, so that people can make informed decisions about what to do, whether they can stay in their homes and put out sandbags or whether they need to leave. But now we're going to go onto my iPad and actually have a look more closely at a storm hydrograph. So let's have a look at a typical storm hydrograph. So typically you'll find three things on these graphs. To the right hand side we can see precipitation, so that tends to be rainfall, and that's given in millimetres. On the left hand side we're looking at river discharge, so that's the volume of water flowing through the river at any one particular place. And then at the bottom we have a time scale. Now there are two types of flow which affect the discharge of a river in a storm hydrograph. First of all, we have the base flow, which is the normal discharge of the river, which we can see bottom right in the baby blue spotty section. That is the river's usual discharge. With the storm flow, which we can see on the key on the left hand side, this is when you're going to see a huge increase in the river's discharge. That tends to be in line with a huge amount of precipitation. And so we call the storm flow the extra discharge of a river, which results from a storm. So as I've already said, storm hydrographs show river discharge, precipitation, and time. They have a base flow, which is the normal discharge of a river, as well as a storm flow, which is the extra discharge of a river, which results from a storm. Now we're going to look at the features of different storm hydrographs. So we'll start by looking at this portion where the bar chart is. We can see that this is the peak rainfall or peak precipitation. As you might imagine, this is the maximum rainfall that occurs. Moving over to the graph line as opposed to the bar chart, always has this characteristic shape. You can see this portion of the graph where it is steeply increasing that gradient. We call that the rising limb, and this is the increase of river discharge. It doesn't necessarily have to occur straight after precipitation. Then you have the peak discharge here, which is the maximum discharge. Remember, you will see that delay because it does take time for the water to find its way to the river. You may also see this described as peak flow. The thing with geography is there's lots of names for the same thing. Because there is that delay between the peak precipitation or peak rainfall and the peak discharge, due to that time taken for the water to flow into the rivers, we call that delay the lag time. So we've dealt with peak rainfall, rising limb, lag time, peak discharge, but what about this falling limb? We can see that negative gradient of the graph line. This is known as the falling limb, and what it's trying to say is that as that storm precipitation levels decrease, in turn river discharge will decrease because less water will be entering the rivers. And then last up, base flow, we can see down here. That's when the river discharge returns to normal. So what factors affect the shape of storm hydrographs? Well, firstly, the amount of precipitation or rainfall. Obviously, the higher the rainfall, the greater the river discharge. Next up, human activities. Urbanisation and deforestation both increase river discharge, and that's because of increased surface runoff. The size of the drainage basin will also affect the storm hydrograph, and actually you find that large drainage basins are associated with less discharge. Small drainage basins are associated with more discharge, which might seem a little counterintuitive. Rock type also has an effect. If you have an impermeable rock like granite, you will see more discharge because that water is not going to soak in. If you have a permeable rock like limestone, you'll get less discharge. So do be prepared to compare these various factors. We can sometimes describe these hydrograph shapes in terms of whether they're flashy storm hydrographs or if they're subdued storm hydrographs. So the classic shape we have here is for a flashy storm hydrograph. We'll talk about the various characteristics shortly. If this graph changed a little bit in shape, so it was more like this, that would be what we would call a subdued storm hydrograph. That's because we have a longer lag time, a lower peak, and a gently sloping rising limb, as we can see here. So yeah, longer lag time, lower peak, discharge peak, and a gently sloping rising limb. And we'll talk about the reasons as to why you get the flashy storm hydrograph versus the subdued storm hydrograph right now. So our flashy storm hydrograph, we know we're going to have a short lag time. We'll have a high peak discharge and a steep rising limb. So those are all descriptions of the graph we would see. Why do we get these various features that we see on the graph? Well, for a number of reasons. You could have had an intense storm or rapid snow melt, steep slopes. So if we consider the geology, steep slopes mean that we'll get lots of runoff into those rivers. A small drainage basin will also give rise to flashy storm hydrographs. In terms of human behaviours, deforestation and urbanisation will increase surface runoff and therefore mean that you're more likely to get a flashy storm hydrograph. So there's lots of different factors you can talk about affecting the shape. If we look at the subdued storm hydrograph then, what do we expect to see on the graph this time? As I've already said, you'll have a longer lag time, lower peak discharge, shallower rising limb. So the reasons for that subdued storm hydrograph will be opposite to the ones we talked about in the flashy one. So rather than an intense storm, we would talk about steady rainfall, gentle slopes, large drainage basins, lots of vegetation. Because remember that vegetation will intercept that rainfall and delay that water reaching the rivers. So let's look at some past paper questions. We're being asked to study figure 1b and identify the feature of the storm hydrograph labelled X. So here's figure 1b. What is X? I'm hoping you can see that that is the peak rainfall. It's the top of the bar chart. Next question, study figure 1a. Suggest 2 reasons for the different storm hydrograph shapes, 4 marks. So here are our storm hydrographs. I'm hoping you can see this is a flashy storm hydrograph. We've got that shorter lag time, the higher peak discharge, the steep rising limb. This is a subdued storm hydrograph. We've got a much lower peak discharge, a shallower rising limb, and a longer lag time. So we are going to state those differences and then give a reason for it. So in the first storm hydrograph, there is a shorter lag time, and that could be due to urbanisation and deforestation, increasing surface runoff, and means less interception takes place. Make sure you write a nice full answer here. What else did we talk about? We said about the rising limb. We could say in the first storm hydrograph there is a steeper rising limb. So we have that flashy storm hydrograph, and we said that that could be due to there being steep slopes which increase the rate at which water enters the rivers. Now we're moving on to fluvial processes, and really these are factors which affect the shape and the flow of rivers, and we'll be looking at things such as erosion, weathering, deposition and transportation, and unfortunately these words do sound quite similar and you do need to know them in lots of detail. So first of all we'll start with erosion, and really this is the wearing away of soil and rock in riverbanks and rivers. Now there are 2 types of erosion, vertical and lateral. So vertical, as the name suggests, involves deepening the river, and this is mainly due to hydraulic action, which we'll talk about lots later. In terms of where you find this sort of erosion, it's mostly in the upper course of the river, so near its source. Lateral erosion, as the name suggests, involves making the river wider, and it involves eroding away at those banks of the river. This is actually more common in the middle and lower courses of the river. So vertical erosion we'll see towards the start of the river, the upper course, that involves making the river deeper. Lateral erosion makes the river wider, and it happens more in the middle and lower courses of the river. Now there are lots of different ways in which erosion may take place. Some of these include hydraulic action, which we've just mentioned, attrition, solution, otherwise known as corrosion, and abrasion. So we'll start with hydraulic action and look at that in a bit more detail. This is really due to the force of the river against the riverbanks. And what happens is there's air that is squashed within cracks and crevices found within those riverbanks, which weakens them and fundamentally leads to their erosion. Hydraulic action, as we've already mentioned, is the main source of vertical erosion, so we know that that river will get deeper as a result of hydraulic action. Next up, abrasion. Now, abrasion can be responsible for both vertical and lateral erosion, so that's making the river deeper and wider. First of all, material carried by the river scrapes away at the riverbank, hence how it makes the river wider. This also loosens material in the riverbank, meaning that that is more easily carried away by the river. Sandpaper action widens and deepens the river, and you also may see that the river gets undercut by rocks rubbing away at the bank. So again, just to mention, abrasion is responsible for both vertical and lateral erosion. Attrition now, another similar sounding word. This time it's rocks being carried by the river, knock against each other and actually cause these rocks to break apart and become smaller. How about solution or corrosion? In this case, the river water itself dissolves minerals in the riverbanks. Also, if the water is weakly acidic, it will dissolve soluble particles. And so this is a lot more gentle, but again, we can see that the river will become wider and deeper as a result of solution/corrosion. So we've dealt with erosion now, but what about weathering? As the name suggests, it's how different types of weather may affect the river's shape and flow. There are three types we are going to look at today: mechanical weathering, biological weathering, and chemical weathering. And there is some overlap with the chemistry specification for some exam boards. So mechanical weathering, the freeze-thaw type of weathering. So what happens here is that water in very cold weather freezes within the cracks of rocks. And when that water freezes, it expands, pushing that crack wider. So you can imagine how lumps of rock will break off those riverbanks. Chemical weathering is all to do with slightly acidic rainwater, dissolving soluble particles, breaking down the rock in a more gentle way. But again, this is still a type of destruction to the riverbank. Biological weathering. Biological always means to do with living organisms. Here it's plant roots which grow in small cracks of the rocks, and as those roots grow bigger, they widen the cracks, causing it to potentially break off bits of rock. Weathering is tightly linked with mass movement, because you can imagine as those small chunks of rocks break off, if this happens in a large quantity, this is what we call mass movement. And particularly if you have a steep slope, which we'll talk about lots later, you'll see a huge movement of material down those riverbanks. There are two types of mass movement. One is soil creep and one is slumping. So slumping occurs when the bottom of a valley slope is worn away by the river flowing. The slope becomes unstable and material slumps down towards the riverbed. This is particularly applicable after heavy rainfall. You can actually imagine how that material will just fall off of the side of the slope after rain, after it becomes unstable. What about soil creep? Unlike slumping, which occurs quite rapidly, soil creep, as the name suggests, is a much slower process. Rather than occurring on steep slopes, you'll see soil creep occur on gentle slopes where weathered material gathers at the bottom of the slope and then it is eroded further by the river. Now we're going to look more closely at the factors which affect weathering, and remember, mass movement is tightly linked with weathering, because once weathering occurs and small bits of rock break off, that means that they're more susceptible to move as a whole. So what factors affect weathering and mass movement, and do be prepared to explain them? So first of all, weather. Obviously heavy precipitation, heavy rainfall will increase the likelihood of mass movement taking place. Next up, the slope gradient. So the steeper the slope, the more likely mass movement will take place, and you're looking for slopes above 5 degrees in order for mass movement to take place. Climate now. Hot, wet climates will encourage biological weathering, because these sorts of climates, the heat, that extra water will encourage plants to grow, their roots get in the cracks, widening the cracks, increasing the chance of biological weathering, which therefore increases the chance of mass movement, because we'll have small chunks of rock breaking off. Now vegetation. If you have more vegetation holding down the topsoil, and this has the knock-on effect of decreasing mass movement. Now we consider altitude. So at higher altitudes, you'll find colder temperatures. Colder temperatures are linked with mechanical weathering. So at very cold temperatures, you're more likely to find that water and rocks will freeze, causing that expansion of the cracks, meaning that bits of rock break off. So remember, that's the freeze-thaw weathering. And again, that will increase mass movement. Last up, the geology. So we're really looking at rock type here. Now, very hard rocks such as granite are less prone to weathering, meaning that mass movement is less likely to take place. Limestone, which is a lot more porous, it's very easily affected by acid rain because remember that calcium carbonate dissolves in the slightly acidic rainwater. This is going to break down far more easily. You're going to get small chunks which break off, increasing the chance of mass movement. Transportation now. Transport, that means the movement of substances. So really transportation in a river setting means how material is moved down a river. There are different ways of transportation. One is saltation, one is solution, and the last two are suspension and traction. So always bear in mind, what is the umbrella term? Well, we're talking about transportation. So how does saltation lead to material being moved downstream? Well, you have small sand-sized particles, so very tiny particles which are moved downstream by the river, and that is saltation. Suspension, this is when small particles are held within the water itself and they're just carried naturally downstream. Traction is when the heaviest material that's sunk to the bottom of the riverbed is rolled along the riverbed. And then finally solution, materials are dissolved in the water and then carried along naturally in this way. Deposition. This is the laying down of material transported by a river. Let's try and think about where this is most likely to take place. So where is that material going to be laid down? Well, hopefully it seems fairly straightforward that this would occur most likely where the river speeds are slower to give it time for the material to be deposited, where there's less discharge, so less water flowing through the river at any particular point, and fundamentally where there's less energy. So a good place for this is where the river mouth meets the sea. So what sort of things, we've kind of already mentioned them, but what sort of things affect deposition? So that will be sediment size, it will be the presence of any confluences, it could be any natural barriers or blockages in the river. If there's low rainfall, meaning less discharge, the gradient of the river will affect it. So obviously a shallower gradient will mean less deposition. Now we're going to look at some past paper questions. State one physical factor that influences deposition in a river. So remember, deposition is the laying down of material transported by a river. You have so many options here. You could talk about sediment size, river speed, gradient, the presence of any confluences, if there's a blockage or any kind of barrier, but they only want one factor, so I'm going to go with sediment size. Explain how abrasion erodes the river channel. Abrasion is a type of erosion, so obviously that's going to lead to the river being scraped away, becoming wider and deeper. But we need quite a specific answer here for the 2 marks. So first of all, we're going to start by stating that material carried by the river scrapes away the riverside, creating a wider channel. You could be really specific and talk about sandpaper action, widens and deepens the river. Explain one weathering process in a river valley. So do you prefer the freeze-thaw weathering? Do you prefer talking about biological weathering, which is all to do with roots growing into small cracks, or maybe even chemical weathering, which is acidic rainwater, which breaks down some of the rocks? So it's up to you, but just pick one and explain it properly. I'm going to go with mechanical weathering. So this occurs when water enters cracks in the rocks. The water freezes when it's really cold, and when it freezes and turns into a solid, it expands, which forces the cracks in the rock wider, and sometimes they break off. Now we're going to move on to how the characteristics of a river change in the upper, middle and lower courses. So first of all, let's understand the terms long and cross profile of a river. So the long profile of a river is if you were to take a river from its source to its mouth. And effectively you were to look at how that river changes from the source to its mouth in terms of the things we've just discussed. So shape, river speed, sediment size, discharge, etc. We'd be looking at how those things change from the source to the river mouth. Whereas the cross profile of a river is if you were to basically cut slices into that river. So you'd end up with just a cross section. So that could be near the source, it could be near the mouth, it could be anywhere in between. So we'd be looking at things like the width of the river, the depth of the river, and at a particular point what that sediment size, discharge and river speed is doing. So going into more detail, let's look at the upper course of the river. So near the source, what would we expect to see? Well, we'd expect to see that the river is deep with steep sided V-shaped valleys. You'd expect to see waterfalls, gorges and interlocking spurs. If you've been near the top of a mountain, you'll notice that there's the presence of very large boulders, very little sediment. So that means that river will be nice and clear. And why is there very little sediment? Well, there hasn't really been enough time for erosion to take place. We looked at that in a previous video, all the ways in which that river bank and bed is eroded away, producing those small pieces of sediment, which basically makes the river less clear. Vertical erosion will be largely dominant here, and that, remember, is the deepening of the river. In terms of human use, you might find hydroelectric power, so dams are built with a reservoir behind which it provides a source of energy from those turbines linking to the generator generating electricity. There's often hill sheep farming, forestry, and it's often a good source of tourism, and that's because the upper course is often found in mountainous areas, and mountains make great places for ski slopes and other alpine sports. As we enter the middle course of the river, we'll find that the gradient is shallower, so those slopes will be less steep, and the river is wider. We'll have increased river velocity, partly due to increased water within that river. The sediment shape will be rounded, smaller and smoother, and because some erosion has taken place, you'll find that there's sediment added to the water, so it'll be less clear. Lateral erosion is the dominant type of erosion found in the middle course of the river, and that will lead to things like meanders, oxbow lakes. In terms of land use, you'll often find settlements, farming and industry in the middle course of a river. What about the lower course of a river? So as we approach the sea, the mouth of the river, again you'll find that the river gets wider. That slope will become gentler still. You'll have increased river velocity due to increased water volume, and that could be due to tributaries adding extra water to the river. You'll have the smallest sediment found in this portion of the river, and that's known as alluvium. That often enters suspension, meaning that the river will be even less clear than it was before. So in terms of how that river's clarity and transparency changes, it will be the most clear at the upper course, and then as you go to the middle and lower course, it will become less clear. Again, we'll see lots of lateral erosion evident, which will lead to the formation of oxbow lakes, meanders and floodplains again. So do be prepared to list these characteristics in the various parts of the river. In terms of land use, you'll definitely see lots of settlements, industry and farming in the lower course of the river. If we now summarise the long profile in both the upper and lower course of the river, at the upper course you'll find that the long profile is steep and the river is narrow, whereas in the lower course of the river, the long profile is shallow and the river is wide and deep. Now remember, with this topic, they could give you an ordnance survey map with a particular river and ask you to identify various characteristics in the upper, lower and middle course of the river. So these are the sorts of things you want to be looking at. Remember, if the contour lines are close together, that would indicate very steep valley sides. So you'd often find that in the upper course of a river. Make sure you can identify interlocking spurs as well as floodplains. When you see that snaking of the river, remember those would indicate meanders, and you might even notice an oxbow lake. In terms of land use, be prepared to identify towns, which would indicate human settlement. Any industry taking place, remember that will be more common on the middle and lower course of a river. Now we're going to look at the formation of waterfalls, oxbow lakes, levees, river floodplains, etc. So let's start by stating what the physical landforms are of the upper course of the river. Remember, you'd expect to see V-shaped valleys, interlocking spurs, gorges, river rapids, and waterfalls. So starting with V-shaped valleys, how do they form? Well, they form due to vertical erosion, which acts to deepen the river. The river cuts downwards due to hydraulic action and abrasion. The river erodes downwards, you get freeze-thaw weathering, which breaks off pieces of the riverbank and causes soil creep. But what about interlocking spurs? Well, very similar to V-shaped valleys, we're going to have vertical erosion where hydraulic action and abrasion cause that river to deepen. What happens next is the river winds and bends in order to avoid harder rock, and then repeated vertical erosion means that parts of the land stick out in order to form the interlocking spurs. Moving on to waterfalls. So In order for a waterfall to form, you need hard rock above soft rock, which means that that soft rock below will be eroded first. The erosion undercuts the hard rock, meaning that eventually you'll get an overhang, and then through vertical erosion and hydraulic action, you'll find that a plunge pool is created which acts to deepen the waterfall. So we've dealt with the upper course of the river. What about the middle course of the river? Here you're likely to find floodplains, oxbow lakes, and meanders. So remember, meanders are those characteristic S-shaped bends in the river, and they can actually be very distinctive in places like the Amazon. But how do they form? Well, the river flows fastest on the outside of the bend and flows slower on the inside of the bend. So what you find is that on the inner bend, deposition occurs because the river has less energy, so more sediment can be deposited. On the outer bend, more erosion takes place due to hydraulic action. The river erodes and deposits laterally. Remember that meanders and oxbow lakes are very tightly linked, because eventually what happens if erosion is such that effectively the S on the meander gets cut off, then you end up with an oxbow lake. So again, how is an oxbow lake formed? Well, we're going to start by saying that the river flows fastest on the outside of the bend and slowest on the inside of the bend. Again, on the inside of the bend, deposition occurs because the river has less energy and therefore sediment can be deposited. The outer bend, we see erosion due to hydraulic action. Eventually, the bank at the start and the end of the meander will meet, and full flow breakthrough will provide a shorter pathway for the river, and then the oxbow lake forms due to deposition on the new riverbanks. Now, a floodplain is the area of land directly adjacent to a river, and it's found in both the middle and lower courses of a river. A floodplain forms when river discharge is high and the river overflows its banks. Now, that river water may infiltrate the soil, leaving behind a layer of material which builds up to form the floodplain. Moving on to the lower course of the river, so what physical features do we find here? Well, first of all, we find that floodplain. So again, be prepared to describe how that floodplain is formed due to the high river discharge, meaning that the river overflows its banks. Alluvium is deposited. You'll also find levees, the river mouth, deltas, and potentially islands. Well, what is a levee? Well, it's natural embankments that form by the banks of the river. How are levees formed? They're created by deposition. So when the river flows over its floodplain, the velocity of the river slows. This means that the river is unable to hold all of the sediment contained within it, meaning that the sediment is deposited. What actually happens is the largest sediment is deposited first, and then the smallest sediment is deposited furthest away from the river, and this is a process known as sorting. And as you might expect, this process repeats over time, meaning that eventually you get these natural embankments known as levees. Now let's look at some past paper questions. Explain the formation of a river meander. So we'll start by talking about how fast the river's flowing on both the outside and inside bend. Remember that the river flows fastest on the outside bend. And then make the full comparison, and slowest on the inside bend. Because of this, on the inner bend, deposition occurs due to there being more friction here. On the outer bend, erosion occurs due to hydraulic action. Now we're being asked to explain the formation of a waterfall. Remember, a waterfall can only occur where there's a band of hard rock sitting above softer rock. Remember that softer rock will erode first. And over time, this creates an overhang. Which collapses as it's unsupported. Moving on to uses of water and why there's shortages and surpluses around the world. She looks so long. Hi everyone. If you've been following my science videos for a while, you know about Lyra, but here she is in geography because she's going to help me with my water quality video. So broadly speaking, what factors will affect water quality? We can divide them into agricultural ones, industrial ones, general human activity, deforestation, which means cutting down trees, and then we'll be looking more at water treatment, both how it can improve water quality but also reduce it if not carefully managed. Now, to do well in your exam, you'll need to provide lots of very detailed answers, so we're going to take each of those categories in turn. So first of all, how can agricultural and farming practices reduce water quality? Well, first of all, liquid slurry, so that's effectively animal feces, animal poo, can wash into rivers and they'll cause a phenomenon known as eutrophication, meaning that the rivers become very lacking in oxygen and all the aquatic organisms die. But in this way, water quality is hugely affected. Next up, with agriculture, remember fertilizers are added to soil to improve the fertility of the soil. These can also be washed into the rivers and the groundwater, making it hugely contaminated. These are not things as humans we want to be consuming in our drinking water. And last up, deforestation is a common agricultural practice. Sorry, there's a dog barking. Now, the reason why farmers deforest, why they cut down trees, is to provide more space to grow crops and more space to rear their livestock. Now, what happens when you cut down trees is that you have fewer tree roots to hold down the topsoil, so you get surface runoff, meaning that more soil and silt flows into the river, reducing the water quality. Now we're looking specifically at how human activity can alter water quality. Now, obviously homes are full of toilets, which if the raw sewage from those toilets is allowed to flow directly into the river, you'll really reduce the water quality because of the huge increase in bacteria in that water. The same is true if you have leakages from sewage treatment plants, so places where that water is treated to make it safe for human consumption. If those sewage treatment plants aren't carefully managed, then you can get massive leakage, which will adversely affect the water quality of surrounding rivers. Another way in which water quality is reduced, which you might not initially think of, is the emptying of chlorinated swimming pools. Remember that swimming pools have chlorine added to them in order to kill any bacteria present and to make them safe for our use. Emptying this chlorinated water into our rivers obviously has a really detrimental impact on the water quality and will affect all the aquatic organisms that live there. The only good thing really that humans do to improve the quality is through those sewage treatment works. If carefully managed and properly cared for, they will obviously remove all that solid waste, remove all the bacteria, and really the effluent from that sewage treatment centre should be really clean water. So therefore, in that way, the water quality is improved. Next up, how can industry affect water quality? Well, lots of factories use cooling systems and they use water in order to cool down their machinery. Now, the output of those cooling systems is much higher temperature water, which gets emptied into rivers, killing many organisms found there and generally upsetting the river ecosystems. I'm sure you've seen lots of pictures in the news when oil refinery spillages take place. This is an awful episode because what happens is all the oil floods into the rivers, into the seas, causing all those poor seabirds to get stuck and widespread death to these organisms. And then the last industrial process I want to talk about is the iron refineries. So this is places where iron ore gets processed in order to make pure iron that can be used in building bridges, settlements, etc. Now you get some really toxic chemicals getting washed out of these processing plants into rivers, and you'll see the whole river turn red. Just as a quick aside, remember the term potable water is just water which is fit for human consumption. So what are the three main stages in managing the supply of clean water? Well, number 1, collection, number 2, treatment, and number 3, delivery to the end user. Where is this fresh water collected from? We talked about this in a previous video. Reservoirs, lakes and rivers, aquifers and wells. Once we've got that water from these various sources, how is it treated? Well, we briefly mentioned at a sewage treatment plant or at a water treatment plant. So the first step is filtration. That removes any solid bits that have entered the water. That could be as basic as stones or twigs. Then you have sedimentation, which removes suspended particles, so little pieces of sediment that make the water cloudy. And then the final step is chlorination, the adding of chlorine in order to kill any bacteria present to make that water safe for drinking. That water is delivered to end users quite often along pipelines, although in less developed countries you'll often find a standpipe where people collect the water in bottles and buckets. So how is the water supply managed? Well, if we look at reservoirs and dams, remember a reservoir is an artificial storage place of water and it often has a dam to hold that water back. Now, that water will be allowed to flow onto the pipelines which supply the houses as and when it is needed, so that can be very carefully managed. Dirty or used water from homes is taken to sewage treatment plants where it goes through those treatments we've just discussed, and then it's piped back to people's homes. Desalination, as the name suggests, involves the removal of salt. So sometimes in some countries, such as in the Middle East, they'll need to get their drinking water from seawater. That seawater contains an awful lot of salt which needs to be removed, and that is the role of the desalination plant. Now we're going to be talking a lot more in detail about the use of dams in managing the demand and supply of water. As I've already said, dams are used to hold back waters in reservoirs, and through careful management that water is allowed to run along pipelines to people's homes. The other great thing about dams is it can be used for hydroelectric power, which remember is a renewable source of energy. When that water is let out of the dams, it turns a turbine, which is like a giant windmill, which turns the generator that can be used to power people's homes through the electricity it produces. So hydroelectric power is a fantastic byproduct of the building of a dam. And for this reason, you find lots of dams. So in Africa, for example, there's over 600 dams, and in Europe, as many as 1,200. The fact that that water is held behind the dam and the reservoir helps to prevent flooding further downstream, and it also enables water to be held back for periods of time when water levels are naturally lower and there is a drought. And this can therefore reduce water insecurity. Now, the Great Renaissance Dam had a huge amount of controversy attached to it. So the people in Egypt are concerned because they have a reduced control of that water, and that water is so important for so many of their livelihoods, so they may end up suffering from water drought. And then the people in Sudan are concerned because when that water is released from the Great Renaissance Dam, it might overwhelm smaller dams and rivers which have smaller capacity. And it's really that ability of dams to control water where rivers cross international boundaries means that there are potential issues created as to who controls the water supply. Now let's look at some past paper questions. Study figure 1A in the resource booklet. Explain 2 ways human activity can affect water quality. So here's figure 1A, and let's try and zoom in on some things which will affect the water quality. So this sewage treatment plant down here is a good thing, remember, because it processes the sewage and ensures that that water gets purified. It gets all those horrible microorganisms removed so it's suitable for household use. The same with the water treatment up here. That will be improving the quality of the water in the dam. In terms of reducing the water quality, this house obviously is going to be producing lots of raw sewage from that toilet right there. It even says raw sewage out. So if that gets untreated, that will cause eutrophication as it enters the river. And again, we've obviously talked about the sewage treatment plant as being a good thing, but again, if there are leaks, we're going to see eutrophication taking place down here as well. We're going to start by talking about the discharge of untreated sewage from houses. Then we'll talk about it from a positive perspective. So water treatment facilities can process the water to ensure there is a higher amount of water suitable for household use. Explain 1 way agriculture can affect water quality. I've already touched on it before. We could talk about eutrophication. We could talk about anything to do with deforestation. Remember, that's cutting down trees to provide more space to grow crops or for livestock. If we were to talk about livestock, we could potentially talk about cattle waste, and that leaching into the rivers, again contaminating the water, as that will increase the bacterial load. Lots and lots of options here. I'm going to talk about the eutrophication answer. So liquid slurry, that's really the feces from cattle, can leach into the river, so wash into the river. And because of all those extra nitrates that it contains, it causes the algal bloom, which is eutrophication. And the knock-on result, remember, is that you end up with the river being starved of oxygen, so all the aquatic organisms die. First of all, why is flooding such a problem? Well, flooding causes damages to people's home, general infrastructure, people's businesses, their factories, as well as communications. Are you coming? Come on. Look, she loves me really. So what physical factors affect flooding? So level of precipitation or rainfall, the density of the river network as well as its gradient. If there's any existing saturation of the soil from previous flood events, that will increase the likelihood of flooding. The time of year and any seasonal changes. So when there's been a lot of snowfall and then the temperature increases, you'll get a snow melt, which will increase the chance of flooding due to an increase in the river's discharge, and steepness of slopes, so the relief of the land. The steeper the slope, the increased chance of runoff and increased chance of flooding. What human factors affect the risk of flooding? Well, firstly, the population distribution and density, various land use, flood management strategies. So if you've got hard engineering structures in place, such as flood walls, that will decrease the chance of flooding. Embankments, allowing salt marsh regeneration. Again, this will reduce the chance of flooding, and we'll look at this in great detail in another video. When you've got increased urbanization, so people building houses, you're going to have increased surface runoff, because firstly, you'll have less interception by vegetation, quite simply because that vegetation has been removed in order to create more land to build settlements. Because building settlements involves an awful lot of concreting, paving, putting down roads, again you'll see increased surface runoff here, and this increases the chance of flash floods. If you're asked for quite a long answer, an exam question with like 8 marks, asking you to analyse the reasons why different areas are differently susceptible to flood risk, we're going to look at both a combination of physical and human factors. So we want to be looking at, whether urbanisation has taken place, if deforestation has occurred, increased concreting and paving, which leads to increased surface runoff, leading to more flashy river regimes, meaning increased flood risk. We want to look at the presence of any flood management strategies, so that's seawalls, salt marshes, managed retreats, etc. Any changes to weather or time of year, so as we said, increased snow melt or increased precipitation. What about the relief of the land? So these are all factors you want to be looking at in that resource booklet, because obviously the case study will vary from year to year. They could ask you in slightly different ways, but these are the sorts of things you want to be looking at. Now we're going to be looking at flood prevention strategies. So broadly speaking, that will be divided into hard engineering and soft engineering strategies. Hard engineering strategies involves building artificial structures which try to control the rivers and help prevent flooding in this way, such as the building of seawalls. The hard engineering strategies tend to be more expensive and they need an awful lot of maintenance. Soft engineering strategies do not involve the building of artificial structures. They take a more sustainable and natural approach to preventing river flooding. That could involve encouraging wetland development. I'm now going to describe the various hard and soft engineering strategies in much more detail. So starting with hard engineering strategies, we'll be looking at the relative advantages and disadvantages. So starting with dams and reservoirs. Now the good thing about these is that water can be controlled, and also it provides a good source of renewable energy in the form of HEP, hydroelectric power. But the problem with dams and reservoirs is they are very expensive. And I have touched on this previously, where rivers cross international boundaries, you're going to have a lot of conflict in terms of who's controlling that water supply, and it could lead to a great deal of water insecurity for countries which are downstream of those dams. The building of such dams and reservoirs also leads to a huge amount of damage to ecosystems and loss of biodiversity as deforestation occurs. Flood embankments and seawalls hold back the floodwater and prevent damage to farmland and settlements. They are very expensive, and again, they will adversely affect ecosystems and lead to deforestation. There is the potential to increase the height of the seawalls as sea levels change, and clearly these will save lives, help prevent damage to settlements, and they are a very effective way of preventing flooding. Although at the beginning there's just a one-off cost, they will need maintenance because in 100 years, for example, these seawalls will probably have been breached and therefore they'll need to be rebuilt. The next hard engineering strategy I want to talk about is river straightening and river dredging. So straightening the river increases the speed of the river, meaning that it can effectively hold more water, which is good when you see increased river discharge, which may lead to flash floods. And dredging means removing lots of sediment, any waste that's entered the river, again meaning that the river can hold more water. So through straightening and dredging, we'll see the river can hold more water, therefore helping to prevent floods, meaning that less damage occurs to people's homes, and it means that people's lives are less at risk. In terms of disadvantages, that river dredging does need to be done fairly frequently, so there's a cost incurred with that. And river straightening, because that increases the speed of the river, it may actually increase flood risk further downstream. Turning our attention to flood relief channels, this is when river water flows into smaller channels where it can re-enter the river further downstream. By removing this excess water, it reduces the chance of flooding and all the disadvantages that come with that. However, this approach is quite expensive to build, and if water levels continue to rise, then these river channels may also flood. Moving on to soft engineering approaches, this includes flood warnings and preparation, flood control schemes, and floodplain zoning. So flood warnings and preparation, in this case the environmental agency monitors rainfall, looks at the chance of floods and issues warnings either across the TV or radio, telling people when floods are most likely to occur so people can be warned and leave if needs be, or put any necessary precautions in place. This could simply mean using sandbags to protect their properties, meaning that their possessions are saved and fewer insurance claims are made. There are quite a few disadvantages with this approach, however. Firstly, those flood warnings may not occur quickly enough, people may not hear them. Secondly, it doesn't actually stop any of the flooding. So although people's lives will definitely be saved, if the flooding is such that people's homes still get damaged, then obviously this isn't a sufficient method. Floodplain zoning involves using floodplains for very particular land uses and therefore restricting the building of houses and factories in these areas which are more susceptible to flooding. So more expensive buildings are built further away from the river in areas less likely to flood. And this obviously reduces damages to these types of buildings. But remember, it's not always possible to change existing land uses, and people will still be inclined to build there and buy their homes there. So it's very important that you check whether your house that you're planning on buying is built on a place that's likely to flood, because in that case it should be avoided at all costs. Flood control schemes encourages the development of wetlands and marshes because these act as great temporary stores of water. They're a very natural and sustainable approach and encourage wide biodiversity, increased speciation. It's nice and cheap, but as with all things, it's not always possible. I think it's because it's cold. Please don't. You're gonna tear a hole in my leggings. She's growling because she hates it when she's moved, but I can't just sit in front of the camera all day. You can find you a warm place to sit, you know. Study figure 1A in the resource booklet. Explain one advantage and one disadvantage of the flood prevention measures shown. So we have details about flood prevention measure in York in the UK, so have a look at what we have here. Definitely use the key look. We have flood walls and gates, and we have a flood embankment. So what's good about the flood walls? Well, obviously they're going to reduce the level of damage caused by the floods, which could save people's lives, particularly in the people living around Earlsborough Terrace. Real disadvantages with flood walls, though. Remember, these are hard engineering strategies. They're very expensive because of the huge amount of work that goes into removing those trees, which they've already mentioned here. To build new flood defences, 14 trees must be removed. So from an environmental point of view, that's terrible because that destroys habitats for wildlife, and it's something that will need maintaining. So for an example, in 100 years, it's unlikely those flood walls will still be here. So we're going to start with the advantage, which is that flood walls reduce the level of damage caused by floods, potentially saving lives, disadvantage, trees need removing to allow flood walls to be built. This destroys ecosystems and animal habitats.